Okay, so let's look at this question. I'll probably have to make two videos just because this will probably take about 15 minutes, and I've got a time limit of 15 minutes on these videos. Okay, so we want to do a two-tailed test. We know it's two-tailed because of the not equal to in our alternate, and alpha is 0.005. And for our critical value down here, it says to use the conservative underestimate. So what that means is we want to look at our two sample sizes. We want to find the smaller of the two, which is 19. And the conservative underestimate is one less than that smaller sample size. So 19 minus 1, we're going to use degrees of freedom of 18. So I'm going to use in Excel um, the t-test uh, with a degrees of freedom of 18. And let's go over to Excel. And all I'm going to do, there actually is a t-test inverse here in Excel, or two-tailed t-test right there that makes the computation a little bit quicker. We don't have to um, worry about changing our 0.005 to something else. We can immediately just go to the two-tailed t-test. So the probability was 0.005, and we're going to use 18 as our degrees of freedom. So there is our critical value, 3.196574, or I think it said to round to 3 decimal places, so it'll be 3.197. And of course, if we look back here, that's exactly what it has, 3.197. All right, now we want to know then what is the test statistic for this sample. All right, now the test statistic, unfortunately, is an uglier computation. Let's go to, so in your documents, your tables and formulas in Blackboard, if we look for the small sample test hypotheses, um, here it is right here. Here's the formula we're going to use. Notice that it has this pooled variance, and that pooled variance is up there in the small sample confidence interval calculations right here. So we're going to need to use this computation right here. And of course, you can also go back to your book, which has this, but this is quicker, I think, to go to the formula sheet than to try to find it within the book pages for the day. All right, so we need to notice subtract our first sample size minus 1 times the standard deviation squared, and our second sample size minus 1 times its standard deviation squared over the two sample sizes minus 2. So let's go ahead back here. I'm going to put on my little draw feature, and I think I can do it right here on the screen beside our problem. So we're going to do the pooled variance. Well, that was not meant to be. That's the thing about writing with your mouse. All right, so let me try again. Pooled variance, little bitty p squared. All right, equals. All right, so we need first sample size is 27 minus 1. That's 26. Times the standard deviation squared. Times 17.7 squared. And I'm kind of out of room over here, so even though it's the top of the fraction, I'll have to kind of put it below. And then we need our 19 minus 1, so 18 times this standard deviation, 20.4 squared. And then all of that goes over the two sample sizes added together minus 2. So 27 plus 19 minus 2. And I'm just going to put that in the calculator. I think it's going to give us 44, but yeah, it does. All right. All right, so if I do that entire calculation in my calculator, putting all of that right there in parentheses and then divide by 44, I end up getting that pooled variation is 355 0.37318. All right, now, um, I'm going to go back to those formulas for a minute just to point out to you the formula we're now going to use. Oh, I can't without exiting drawing, so you might want to write down that pooled variation. We're going to come back to that in a minute, so I'm going to exit the drawing. All right, and then here is our test statistic calculation. We're going to do mean 1 minus mean 2 minus the difference. Now we're going to talk about that for all of our examples, the difference is always 0, but it doesn't always equal 0. Everything we're going to see in this course, it will be 0, but of course we learn the formula this way, so if you go on to another statistics course, you'll know that difference isn't always 0. It is for the examples that we have. But notice the bottom, we're going to do the square root of the pooled variance that we just found times 1 over our first sample size plus 1 over the second sample size. So let's go back and let's fill into that formula. All right, now, I said that that difference is always going to be 0. Well, it comes from our null hypothesis. So if I were to take this mean, the second mean, and move it over to the left side of the equation, I'd have mean 1 minus mean 2 equals 0. So the difference between them is 0. So we know from the null hypothesis that that difference is actually 0. For all of our cases, it will always be 0. All right, so let's do our t statistic. We're going to do mean 1 minus mean 2. So mean 1 was 66.1. And mean 2 is 54.2. And then we really don't have to write minus 0 because it doesn't change our calculation. All right, now down on the bottom, we're going to have the square root of the pooled variance we got just a few minutes ago. So that pooled variance was 355.37318. Trying to write smaller just so we got room here. Times 1 over the square root of our first sample size, 27, plus, and I'm going to kind of have to go to a different line, although of course it's not supposed to be on a different line, 1 over 19. Now be careful when you enter this in the calculator, you want to make sure that all of this is in parentheses like that so that the square root gets taken over that entire quantity. And then when you put that in your calculator, you do get 2.10807, which of course is what we get when we round to 3 decimal places there. And of course, that is not bigger than 3.197, so it's not in our critical region, and then we are unable to reject the null, fail to reject the null. So the answers that you got down here were correct, just you didn't have these statistics up here to help you through the problem. Okay, I'm going to do the other one in a separate video just because I'm afraid it's going to use up too much time. So